Hello, welcome back to More Fun Fixing It. It's time to fix something else. It's another Spectrum. This is one I've already fixed. I'm just going to check my capture device is working. It's very noisy. I really need a better solution for this. Everything I try seems to have that noise on it. It could just be my bench power supply. Anyway, this is what we're fixing today, this Plus. So let's get this one out of the way and have a look at this. It says, interesting sound coming from this. And I've looked at this one in a triage episode that you might have seen on my channel, and I noticed that it had no activity and good voltages. The tails look a bit cracked up here, so I'd be surprised. Yeah, this one's really cracked. I'd be surprised if the keyboard works. Let's get it out of the case and see what it's doing. So I've already gone through the basic checks on this, but I'll do them again just for completeness and just in case I missed anything the last time. I can't trust my memory, so let's do them again. Right, on resistance, I'm just going to check between ground and the input leg of the voltage regulator, and that's kilo ohms, so that's good. As long as it's not shorted, I'll be happy to at least turn it on. And the output side is good, and then I think this is -5 is good. 12 volts, this is down on the lower RAM. 12 volts is good, and 5 volts is good, because the lower RAM needs all of those voltages to work and to survive. And then over on the other side, just quickly check the resistance on the coil, which appears, yep, that's good. That's just a bit of capacitance in there somewhere. Yeah, as long as it goes open after a short while, that's fine. I'm just going to put this on diode check mode and then check. I always start with the black lead in the middle of TR4 down here, which has been worked on. Let's open, and open on the other side. And red lead in the middle should be, yeah, about 0.7-ish. That's good, both sides. And then black lead in the middle of TR5, 0.7 that way and 0.7 that way. And it should be open that way. And then 1 point something that way. That indicates that they're okay. I do have some issues down here though. There's a bit of a scorch mark on one of the caps, so I'm going to show you that under the microscope. And you can see that cap there has got a bit of a burn mark on it, and then there's some funky stuff going on underneath TR4 as well. I'm not sure what that's all about, why it's burnt. And why that's burnt. So I think that burning and this burning are obviously linked in some way. TR5 hasn't been changed, but yeah, TR4 has definitely been changed. None of these other caps have been changed. These Gelec ones are the original brand that were put into Spectrums. Is there anything else worthy of note? The CPU has been changed. You can see this. These are factory solder points here, solder joints, and these ones have been reworked, and you can see there's like crystallized flux all around there. So that's just worth looking, just in case something has broken along here, because this flux, you know, some certain types of flux can become corrosive. And you don't know what sort of flux they've used, and it could have eaten away these traces. But it looks okay. There's a bit of solder mask missing there. And a few blobs of loose solder. More over here. Oh, there it goes. I'll sweep those off the board with a brush later. Yeah, they've been quite messy with their solder. It's splashed around all over the place. Let's give that a clean. I don't think the flux is going to come off very easily, so. But the main thing I'm doing here is just making sure that there are no blobs of solder bridging anything anywhere. There's just a little bit here that I don't like the look of. It's quite difficult to clean this old flux off. It's probably worth heating it up and getting it off that way. It does look actually like it's dissolving. But you'll always find some that hangs on in places like this. It's in a corner like that. You're really difficult to, without manually scraping it out of every little bit. Anyway, it seems to be in good enough condition that we can power it up with a diagnostic card in. So let's do that next with current limited power supply, just to protect it in case anything goes wrong. The edge connector is really funky. It's not a thorough clean, but a quick going over with an eraser should just take off enough to get a good connection, and I'll spray some contact cleaner in the inside of this edge connector. Right. Oh, it is making a. Oh yeah. So last time I started this up, I made a note on the case here that there was no activity in good voltages, and there are good voltages that I can see off of there. Let's just check that. Let's see what's coming in is 8.6, not ideal. 4.9 going out, that's good. And the -5 is 5.12. The +12 is 12.02, and 4.97 is the +5. Okay, so the next thing to check is the reset and clock. Now we've got voltages, then when you do reset and clock, those are your main targets to check initially, your first things that you should always check. So let's get my Zoe multimeter here, my Zoe scope, and on this edge connector I've got access to all of the edge connector pins, and they include a reset line which is there. So if I turn that on now, yeah, reset is good. And clock is up here just under that pust character. Clock is oh yeah, something weird going on with the clock. This is really weird. I'm just having a little poke around here, and these are all the data lines, and they all look good. I wonder what happens if I manually reset it. That address line looks really weird. That's address line 0. And that doesn't look right. These ones look more normal signals. They're, what are they? 1, 2, well, they're actually a little bit low. That is 5 volts, that one. These are a bit low. Well, the clock has settled down now. What happens if I reset it? Now it's just going nuts. And all those voltages have changed. TR7 is quite hot. TR7 is something to do with the sound circuit. So let's pop that out and see if it's actually faulty or not. And I have tried measuring. Actually, let's do that now. Right, I'm not sure how much you saw in that segment because my camera wasn't plugged in, so my battery died, and I might have lost quite a bit of footage. I found that TR7 was actually getting quite warm. It's not hot. It's not warm at all now. And TR7 is part of the audio circuit, and with this audio buzzing noise, I think it's worth having a look in that area. I know from previous videos that testing, there's a D9 diode here that and when you test it in circuit, it doesn't give true readings. Nope. Although 1.27 volts one way doesn't sound very good, and 0.6 the other way. Let's try TR7. Yeah, that's got that same 1.2 volts one way and 2.5 that way. Something's wrong here with either one of those. Oh, well, let's just check the resistance of the... Just going to test it with this. Of the speaker. It should be, I think it's 40 ohms on this one. Oops. Okay, we've got a broken speaker as well. Yeah, it says 40 ohms on it. Well, hang on. Oh, 38 ohms. I was just measuring poorly. There we go. 38 ohms. Just needed to break through the crust. So we've got a good speaker. It's either TR7 or that diode. Let's pop out TR7 first. Ouch, that's still hot. Putting in my fancy new chip tester, component tester. That's good. All right, so let's take out that diode then. I think this is all right. Yeah, the diode's okay. So does the computer now run now that I've taken those two components out? Let's put those to one side for a minute. Well, maybe the transistor TR7 was just running very hot because it was being pushed quite hard. This could be a ULA problem. Sound is generated in the ULA, so I think the sensible thing here is to grab another working board, the one I had earlier, and test it in here. It's quite difficult to get the ULA out of these when the heatsink's in the way, but a screwdriver down the back of the heatsink and then just loosen up the pins on that side seems to work well. And this is the board that we're working on is a issue 4B, and it's got a -7 ULA, which will work in anything if it's working. The ULA is fine. That's really good news for two reasons. One, it makes the video more interesting. And secondly, we don't like broken ULAs because they're expensive. And basically, write the machine off. If you have a broken ULA, it's more expensive to replace a ULA than it is to buy another Spectrum. So At that point, any insurance company would say, I'm sorry, sir, your car is a write-off. Maybe you shouldn't have driven it into that tree and then reversed into a river whilst on fire. So with some contact cleaner in here, just in case, I can put this chip back, give it a quick test. I'm using the wrong lead. Just realised there's no composite mod on this one. I need my instant composite mod from Henry. It doesn't matter how many times I do this, I will still make the same mistakes. You're welcome. Right, let's have a look without the diagnostics in, see what display we get. Just a black screen. Nothing on cap. Oh, it's trying. I wonder what this does if I plug it into a TV, because the capture cards are always a bit more fussy. I get a clearer image now, and there are, I mean, the screen is really heavily corrupted, but there are some visible stripes running up and down the screen, vertical stripes, which indicates a RAM problem, possibly, but that could also be a CPU. But there's also I've got no picture now. Oh, there we go. Yeah, there's also no white border, so the CPU is not running. So my big suspect at the moment is the CPU. So the other gamble here is that it could also be the caps. That one is burnt, but I'm pretty sure it's actually okay. That's just like superficial burning, and I have gone round the caps with my ESR meter, which isn't, you know, a conclusive test, but it does give a good indication if a cap is terminally bad. Let's try this one. For that 22 farad cap is measuring 22 microfarad cap is measuring 48 microfarads, and this one is measuring 20. So that one could be bad, and that's part of the DC circuit. That's a 1 microfarad cap, and that's okay. This is a 4.7, and that's okay. This is the reset cap, which is often bad. That is fine. That's a 1 microfarad, and that's okay. I think this is a 22. Oh no, it's another 1. Yeah, that's fine. This is a 22 here. That's okay. These hundreds, fine. Fine. This is a 22. That's 48. That one's measuring as well. And there's a couple of 22s over here. That one's 20. And this one is 31, but these are part of the, I think, the video generation, so not so important. But those two are double their capacitance, so maybe let's just take those two out and put some new ones in there. I might recap the whole board anyway, and then see what happens. Oh, slipped, and I've scraped right across the motherboard there. I've cut these legs off really short, but still bent them over. Don't think. I'll have to check those traces, and cover that up with some solder mask, but I don't think I've done any lasting damage. I've really cut these off flush to the board. Now what does it say? Yeah, 20 microfarad. There's nothing wrong with that. 2.2 ohms ESR. Yeah, I don't think it's the caps. I don't think it's the CPU. Let's take the CPU out. Put this back in. The later boards, the caps don't often go bad. Right, I need to get this heatsink out of the way, pop that CPU out, and then test it in another board. Oh yes, it's the CPU that's already been worked on. What are these like? They're not bent over, so I should be able to just desolder these, and they've got loads of nasty flux on still. Definitely going to use heat to loosen this one up. Probably worth having a look under the microscope on this side as well, just to make sure that the previous work that was carried out on this didn't cause any damage. These traces are barely stuck down, so it's really easy to lift them up. Yeah, that all looks perfect. Check that back side. It needs a good clean. While it's warm, actually, I'm going to just see if I can get some of this flux off. That looks better. I think that is just a bit of solder sticking up. It's the same on these ones down here. I'll go over this with some braid in a sec. And these bits of bare traces I'll have to cover with solder mask. Very easy to get a bridge across something like that. I think these are all mostly caused by me. Maybe, I'm not sure. Can't remember if they were there, but they look like they were. Bit of cotton. Yeah, everything looks good. This bit over here is where I scraped across the board. I'll have to check the continuity of all of these now. Most of them head to the edge connector, so not the end of the world, but let's just make sure they're okay. That one. That's broken. Perfect. Last one is 2, I suppose. So this one. Goes to there. And then this one. Goes to there. All right, I'll cover all that up with solder mask later. Let's get this CPU tested. There was some talk of Z80 CPU testers on my Discord. I might have to pick one of those up. Now I need to find a ZX Spectrum with a socketed CPU. Now this one says my issue 2, recapped, fully socketed, bad membrane. So let's try and have a look to see what's in here. Probably Harlequin or something in here, knowing me. Okay, let's check it works. This one is, right, it's a horrible output, but it is working. Now what does that do? It still works. The CPU is fine. Okay, I need a good baseline now. And the only way to do that is if I recap that whole board and then start from the assumption that everything else is working, that it's got, you know, the power circuits are working as they should be, that there's not too noisy DC voltage going into there. There's a, you know, a lot of smoothing that might be missing. Yep, let's recap that whole board. One there, here, yeah, a couple down here, one here, and two here. I've just adjusted my method slightly because normally I would go around with a soldering iron and lift all of the pins because they're bent over away from the board to help get the end of the soldering iron, desoldering gun onto the end of the pin. But these have been cut off so flush I can actually just put the desoldering gun straight onto it, even though it is bent over, and it still fits into the end of the nozzle without lifting the pad up. But they're cut almost flush. Most of them are cut almost flush with the board. This one isn't. Both those hundreds are just falling out. That's a 1. This should be a 4.7, this burnt one. I'm just wiggling each one just to make the solder that's still left on there let go. And then it's easy. Once I can feel that it's wiggling. Oh, I didn't do that one. Once I can feel that the legs are loose, I just use a pair of tweezers just to lever them out a bit. 22. I think this is a 1. That's a 1. Let's write these down. So that's a 1. That's a 1. That's a 22. That's a 4.7. That one's a 1. 22. 22. All the rest of these are hundreds and 122s. Tangled up on everything. Get out of the way. Okay. Let's get some new caps. Right, socket. No bent pins. Let's see if that's made any difference. Check on the screen first. We still haven't done a composite mod, so I'm still using the instant composite mod, the instant Henry composite mod cable. Everybody needs an instant Henry. It's working. It's not a great signal. Let's see if I can get it to display on capture. Yeah. Oh my God. It was just caps. Lewis on my Discord, he's a very active member on our Discord, and he is someone who really does bat for the cap everything side. He's going to be laughing his backside off at this one. It was the caps. I should have just changed the caps to start with. But I can't do that with every single one. So my camera died and I lost a bit of footage, but what has happened is I've painted solder mask on all of the bare bits of trace around here, and that scratched trace, where was that? I've made such a good job of it, I can't find it. It's here. Yeah, it's just going across there. So I've painted all that and I'm just going to cure it now. Sound is now working. I've put TR7 and the diode back in and down here. And yeah, everything seems to be good. But let's give this a blast of death rays. There we go. You would never know. Looks really good actually. I'm quite pleased with how that colour matches. Right, let's put it back in its case and try that keyboard as the final part of the repair. Test that reset switch as well. Might be all right. It has now passed its functional test. Ah, the last job that we need to do, you don't need to do, I need to do, is composite mod it, because it's not composite modded. Let's do that super quick. You've seen this a million times, so I'm going to scoot through it. Composite modded. Just make sure it still works. Yep, it looks horrible because the connector is a bit grotty. Need to clean that up. That's much better, much more stable. Yeah, good. Reset. Yay, reset works. Reset works very well. Nice pause. I give this a 10% chance of working. There we go. Oh my God, one's not working. Let's just try this without seeing. Yeah, some of the keys are working, but some of them definitely, oh God, it feels horrible. Some over here are working, some over here are not. Crack membrane, yep, let's button this one up. Issue 4B, full recap, bad keyboard. So issue 4B, full recap, bad keyboard membrane. And I'm happy to put a More Fun Fixing It sticker on this one because I've fully recapped it, and these are not a warranty. But it'd be nice if I see them out in the wild somewhere. It does just mean that I've worked on it. I'm not guaranteeing my work. These are 40-year-old machines. It's going to break again. Okay, I hope you enjoyed that video. I enjoyed getting to the conclusion that I should have got to much earlier, but it's always fun. The journey is always fun, and fixing things is always fun. So yeah, if you enjoyed that, then give me a like and subscribe. Maybe have a look at my Patreon. You can see early access videos and behind the scenes content, exclusive content, and a special Discord chat channel in my Discord, not my Discord server, in the Retro Hardware Discord. Thanks for watching. I'll see you in the next one. Don't know why I banged the desk then. That's easy to edit. Let's just keep banging the desk. Because why not?